So the next form of sort that we're going to look at is something called a bubble sort. And this sorting mechanism is actually pretty slow and inefficient when you get up to a large amount of data. It's fine when you're dealing with small amounts of data. The problem is that the reason why people will implement this one and use this one quite often is because it's probably the easiest one to actually program. It's very simple in its nature. So it kind of works in the same idea where you have half the list being sorted and half the list being unsorted. But in this case, we're going to be looking at it and we're going to sort from left to right, where the right side is going to be the sorted section and the left side is going to be the unsorted section. The difference is here, when we first start it, the entire list is considered unsorted. Nothing is sorted yet. And the way that it works is it typically has two pointers. The first pointer is pointing at its starting value, or its starting value, yes. And then the second pointer points at the next place to actually sort up to, so where the sorted list actually starts. Now, right now, the sorted list is at the very end, so there's no real place to go to. And the way this system works is essentially it says, look at the value and look at the value next to it. Which one is greater than and which one is less than? Should they swap places or should they leave things the way they are? So for example, when we look at -7 and 93, we see that -7 is greater than 93. So these two should swap places. So the next step looks like something like this. Now we have -3, 97, 5, 4, and 3. We'll just use commas to simplify this. So that's after step 1. But we continue on with the 97. We're now looking at the next set of data. So now we're looking at these two pieces. We say, well, is 97 greater than 5? Yes, it is. So again, we have to swap it. So this goes into -3, 5, 97, 4, and 3. So that stage is done. Now we're continuing on. We look at 97 and 4. And we say, well, is 97 greater than 4? Most certainly is. So we have to swap again. So we come down onto the next step. We have -3, 5, 4, 97, and 3. And now we're looking at the last two pieces. So is 97 greater than 3? Most certainly is again. So this leads us into -3, 5, 4, 3, 97. Now what we know here at this point is because 97 is now at the end of the list and nothing was greater than it, that 97 is considered a sorted item. That means the next item to be sorted, when it's all done, the next greatest item is going to be here at the end. And we go back to the start again. We start all over at the very beginning. And we continue the process. When we're all done, the next highest number should be exactly where that end index is. So we start off at -3 and 5. We say, well, is -3 greater than 5? No, it's not. So those values don't swap. But then we look at the next set, and we say, well, is 5 greater than 4? Yes, it is. So that means on the next step, we're going to have -3, 4, 5, 3, and 97. Now we're looking at the next step. 5 and 3. Is 5 greater than 3? Well, yes, it is. So this implies the next step, which goes to -3, 4, 3, 5, 97. And since 5 is now in the index slot of the end pointer, we know that we now have 2 sorted elements and 3 unsorted elements. So we have a divide down the middle. So now the end pointer is pointing at this item. So the process continues. And again, we look at this and we say, well, is -3 greater than 4? No, it's not. So it looks at the next two. Is 4 greater than 3? Yes, it is. So it swaps it, and we end up with -3, 3, 4, 5, 97. Well, 4 just ended up in that next end slot. So that means we have 3 items here. and 2 in the unsorted list. So our sorted point is at this point. And we start back over again. Now we can visually see that it's already in sorted order, but the algorithm doesn't stop. It needs to actually verify that we're done. So it checks the last two elements. It says, hey, is -3 greater than 3? No, it's not. So 3 stays where it is, and it is now part of the sorted set. So the next step would look exactly the same. It would say -3, 3, 4, 5, 97. We'd have our box around everything, but this time are sorted at this point, which is the second last element. So, and then now the end pointer is pointing at the same place the start pointer is pointing at. So in that case, if they're both pointing at the same spot, that means that element must be sorted. So we are all done, because the whole list is now sorted. So to break it down and summarize, essentially we look at each element and we say, are you bigger? If you're bigger, we shift you to the right. And we look at the next two sets. All right, and we say, whichever one's bigger, make sure it's on the right. And then the next two, and the next two. And we keep doing this until we shift all the way up to the last unsorted element. And then we're all done.